So let's finally solve an integral using integration by substitution, okay, after 3 videos. So I'm going to explain you the steps of integration by substitution through an example. Okay, so let's get started. What is the first step? Identify the inside function. Look at the inside function. What is the inside function here? Well, it's look like x square plus 1. Identify it. Then use its derivative to confirm whether we can use integration by substitution here or not. So what is the derivative of x square plus 1? It's 2x. Do we have 2x? Well, we don't have 2, but we have x. So that's okay. We can be off by a constant multiple, right? So yes, we can use integration by substitution here. Alright, so that's good. Then go to the second step. Define a new variable where u is the inside function. So we defined a new variable u, which we call the x square plus 1. So u is x square plus 1. Then the third step is, so first step, second step done. Third step is differentiate u with respect to x. Now that's a part that you forget often a lot. So differentiate u with respect to x. Write it as du over dx. You have to write it. I will explain later in a minute why. So du over dx, derivative of x square plus 1 is 2x. Alright, now then what it says is find dx in terms of du. So here dx can be written, we can take dx to the right by multiplication and 2x to the left hand side by division, right? So if we change this, du over 2x is dx. So we find dx in terms of du. That's the third step. Now the next step is replace everything or rewrite this whole integral using u. Make a change of variables. Change it from x to u. So let's do that. So now first start with, okay, so first start with inside function. So we can easily write x square plus 1 is u because we define our new variable u to be the inside function. Now x can stay here. Okay, now what is dx? Dx is du over 2x. What you do is now you can see x cancel out, right? X cancel out. So what we get is eu over 2 du. So simplify your integral and get your integral from totally from new variable. That means if your new variable here is u, so you cannot have x somewhere in the integral. Okay, so you are going to change your integral from x to u completely. All right, now that's done. Now look at the integral that you got. Well, can we integrate e to the u over 2 easily? Now integrate. Yes, we can take half outside, that's a constant, so e to the u. If you integrate e to the u, what we get is half e to the u. Integral of e to the u is e to the u plus arbitrary constant c. Don't forget that. Final step is, now once you are done with integration, replace u with the variable to the original variable x. Convert your answer to the original variable x. So here half, what is u? U is x square plus 1, right? So this is your solution. This is what you get after you integrate x times e to the x square plus 1. Now let's pause here and discuss. I want to address several things. Now why do we call this method integration by substitution? Because for inside function you substitute u. You made a change of variable. Understand that. Okay, that's very important. So that is why we call it integration by substitution. We do a substitution. Now here's the most important thing about this problem. I have seen many students do lots of mistakes in integration by substitution, and 90% of them coming from this mistake. Common mistake number 2. What is it? The mistake is, yes, you identify the inside function and you name it as you do everything correct except you don't change this dx. Let me tell you why. Let me do this problem in wrong way. So you have x e to the x square plus 1. Oh, I know the inside function which is x square plus 1, so it's u. So you write it as e to the u and you say dx, or that's just du, and you just integrate this. You don't even think about that x. Okay, or you write x here and you stuck, oh, what I'm gonna do here, well, the integral here is x, e to the integral of e to the u is e to the u, so this is my answer. No, this is wrong. Now, integration by substitution, here's the important phrase that you should remember. Integration by substitution, when you do integration by substitution, you do two substitutions. Always remember that you replace two things. If you forget to replace one thing, you should think back about your problem. What are the two substitutions? First is you replace inside function by u. That's the first substitution. Second substitution is you replace dx by du, but using this process. Don't forget that. Okay, so do this two process without forgetting them. Okay, now why is this important? Think about this. All right, so in integration by substitution, these are characteristic in simple and medium level problems. Okay, until you master it, until you get really comfortable with integration by substitution, you should think about these things every time you solve a problem. Okay, after you master it, you don't have to think about it. It will naturally come to you. So here's the thing. Look at this carefully. Look at this problem. I choose my u to be x square plus 1. I wrote it in this format. Why did I do that? Because I need dx. I need dx in terms of u. Okay, don't just replace dx by du right away, because du over dx, okay, the derivative of u will help you to cancel out the derivative of inside function. Okay, see, when we replace dx by du over 2x, we were able to cancel out something, right? At least for easy and some medium level problems, you will see that cancellation by yourself. Try to do it by yourself. Try to show these steps and convince yourself that you're doing the problem correctly. Okay, if you know what I mean. All right, so those are the characteristics of a problem where you use integration by substitution. So let me do one more problem slowly, just like that. Let's integrate x square root x square minus 9 with respect to x. Okay, what is the inside function? Identify it correctly. It's x square minus 9, right? Now double check, make sure that you can use integration by substitution here. What is derivative of x square minus 9? Derivative of x square is 2x, derivative of 9 is 0. So do we have 2x somewhere? Well, I don't have 2, but I have x. So yes, you can use integration by substitution. So two substitutions. Write du over dx. Please do that. Please write du over dx. Okay, so derivative of x square minus 9 is 2x. Okay, so now find what is dx. So dx is actually, if you switch, now do this very carefully. Okay, dx is du over 2x. This is one of the steps that you have to be very careful. Sometimes you might write, oh, dx is 2x du when you take 2x to the other side. It's wrong, right? You have to do division. So that's another place that you do mistakes lots of times. Okay, all right, so now let's replace. Let's rewrite the integral. So write x. Okay, first replace the inside function, which is u. X square minus 9 is u. Dx is du over 2x. Now do I cancel out x? Yes, do I cancel out something? See that cancellation by yourself. So this is square root of u over 2. Now my integral is from only in terms of u. So good. Now I can rewrite square root of u as u to the half. So if you integrate u to the half, well, we can take this half outside, this 2 outside. So if you integrate u to the half, what you get is here half u to the half plus 1 over half plus 1 plus c. Okay, so now let's simplify this furthermore. Half plus 1 is 3 over 2, divide by 3 over 2. So dividing by 3 over 2 is same as reciprocal multiplication. So we can multiply by 2 over 3. So half times 2 over 3, u to the 3 over 2 plus c. 2 cancel out, so it's 1 over 3. u to the 3 over 2 plus c. So I simplified this to the death. Now let's write the final answer here by replacing u. U is, if I recall correctly, x square minus 9, right? So the answer is 1 over 3. U is x square minus 9, 3 over 2 plus c. This is what you get after you integrate this integral. Okay, all right. So in case if you have forgotten these steps how to do this basic integration, check out the video that appears above on this video, in the link that appears above on this video, and click on the video that appears here in the main video to go to the next video to watch more integration by substitution problem solved. So I will catch you there. Thank you. Bye bye.